Okay, on the bench today, uh, oh boy, it got deep quick. As if I've ever done this before, you know, shot a video of an actual repair on an actual workbench. Welcome to Display Tech Resurrection 101. What we have, God, I feel stupid saying this, but what we have on the bench today is a Heathkit digital multimeter model IM-1202. Now, I showed this to my baby kid, my youngest son, the 29-year-old. And I asked him if he'd ever seen a Nixie display. He said he'd heard of them, but had not. So I showed him this Heathkit digital multimeter. And I switched it over. I explained how a Nixie tube works. And I explained that they're just neon tubes. They're not like amplifying vacuum tubes. And then after I explained how they're built in layers, I said, watch this. And I switched this on to the AC volt range, like I'll do now. Watch how the display on the far right hand, the LSD, the least significant digit, watch how it wanders backward and forward. Now, when my son saw that, he thought it was amazing. Well, actually, he said, cool. This is not the subject of today's resurrection video, however. So, please ignore that scary scribbleness in the background. I'm going to pause this one moment. Nor is the star of the show our friend from Andromeda. I hope I don't scare you. Hang on. Okay, this is the star of the show, and this is a Heathkit frequency counter, model IM-4100, and I believe it also does event counting. I'm not sure. But full disclosure, I've already plugged it in and turned it on. I will not be restoring this old thing, but I will be resurrecting it. And you'll see what I've done to it after I do it. I'm probably not going to try to do that on camera because I'm just not very good at this. The first time I plugged it in and turned it on, the display was missing some segments, and I noticed that the gate LED was locked on, and therefore it was not counting. And I reached around back. Here, let me turn it on. Let's see if it's still have a problem that I discovered. Okay, so the gate is operating right now. On the rear panel is a switch that lets you select between the internal and an external time base. And that switch is funky. It needs to be cleaned. So as of right now, that's all I know about this unit. I have not looked at the schematic. I have not looked at the schematic for it, and I do not know what type of display architecture it uses. And that's kind of what I want to talk about in a moment. When I first turned it on, though, the segments that are missing were fading in and out. I see now that there's a hard failure, which is fine. I'm going to pause this, and unfortunately for you poor souls, I'm going to break out my clipboard and show a doodle for mostly younger hams or non-electronically oriented hams. And I just want to talk a little about display architecture, of yesteryear, and I'm going to venture a guess as to how Heathkit designed this unit. One moment. Okay. Before you clown on me, hey man, I'm a retired baby boomer. So, for you folks that don't care about anything from this point forth, yeah, just bail. That's my advice. Bail on the video. For you younger hams, or those not versed in this type of mumbo jumbo, basically over here is what we have was display technology early in the discrete digital 7400 series logic, that time frame. And typically what you have here, this chain of chips going this way, it's a chain of decade counters, divide by 10 counters. I'll talk about part numbers in a moment. You input a signal, your signal to be counted here. It starts dividing down. These are a series of latches. From this point forth, the data flows up in this direction in each chain that's connected to an LED. These are latches, and what they do is serve as a hold and display function. It's a sample and hold circuit is what it is. So this data is 4-bit BCD, binary coded decimal data. The output of these latches is as well, and the data then is input on a BCD to 7-segment decoder chip. And so if you let this thing run free, these would be a blur, especially on the right hand side. So what you do, you make your measurement, you hold it and display it, and then while displaying it, you're making another measurement. When that measurement's done, update, hold, and display. And so the way they accomplish that is by using a time base and inputting the signal to a dual. You can do it different ways. You can do it with a dual monostable timer chip, and a 74123 is an excellent chip. And what you do, this time base determines how long you count for. You count, and then you update. It outputs a pulse, which updates, then immediately outputs another pulse to reset. These pulses are exceedingly short, and it's edge level triggering. So this pulse goes positive, then negative, and that immediately triggers this pulse. And on that negative edge is when you update or reset. So hopefully that makes sense. You've got our time base that's going measure, display, and reset. Measure, display, and reset. Measure, display, and reset. Over and over and over. The longer you count for, the higher this will count, and you can take it from there. So that's discrete logic. Typical decade counters back in the 7400 series of TTL logic would have been a 7490. A typical latch, 4-bit latch, would be a 7475. A typical BCD to 7-segment display decoder, a typical one would be a 7447. After the initial 7400 series logic came a lower power and faster logic, and that being the 74LS series for low power Schottky. Other than the LS designator, the chips were pin for pin and voltage level compatible. After then, another improvement came along, being the 74HC series for high-speed CMOS. Now, these devices were, I may be wrong here, but I believe they were voltage compatible. I'm not sure on that. But they used the same numbering scheme, such as 74HC00. After the high-speed CMOS 7400 series became antiquated, that entire naming nomenclature was replaced by the 4000 series CMOS logic. Okay. Oftentimes in vintage equipment, man, I've seen stereo equipment like this, that have a million little segments on a vacuum fluorescent display, and every single line for every segment is a physical conductor leading from the board to the display. And flat flex cables are amazing for that application, and they are also very problematic. They're still in use today in our most modern rigs, and they're still problematic. Another way of doing things to save on conductors is to multiplex the same type of architecture, but the main difference being the outputs of all your decoder chips are all connected in parallel and then run up to a display board. If you have 8 digits here, 7 segments per digit, look at the savings in conductors. 8-digit display, 7 segments, that's 56 segments. Throw in another 8 decimal points, that's 64. Throw in another, you need a lead for your common, then you need a lead to enable each one. So, oh dear Lord, man, you can end up with 100 conductor flat flex cables running from your main electronics to the display board. So, therefore, you multiplex. Tie everything in parallel, and then when you're ready, what you do is you have a free running, basically you know what I'm talking about, a brigade counter chip. And what it does is it turns on 1 digit at a time and 1 decoder at a time. It doesn't even turn on 1 digit at a time, and well, I'll talk about that in a minute. But in this technology, you turn on 1 digit, 1 decoder chip, and 1 display LED at a time, and you just start sweeping it electronically. And now then, you've also dropped your current consumption from a monster amount, in the case of a big display full of segments that are all lit, to the current consumption of a single display. And then they've gone to the next big step forward would have been in LSI technology, large-scale integration. And when you reach that level of display technology, now they're not multiplexing by decade anymore. They're multiplexing by segment, at segment level, and even using an LED display, even a huge display. Using this technology, your current consumption is that of a single LED element, because it's all swept at such incredibly high speed that you need a fast camera to catch it, and your camera will. So, I'm sure I forgot to say a dozen things and probably said a dozen I shouldn't. So, in my mind, it makes sense, but it's hard to. I'm not a teacher. So, in regard to that Heathkit frequency counter, the IM-4100, I haven't looked inside the unit and I haven't looked at a schematic. What is my guess? I don't know what year it was produced, so I'm going to say nay, negative, not multiplexed. And when it comes to, I'm going to say yes, they used a discrete technology. And oh man, I forget how many digits it is now. Oh well, I don't care. I say that they're going to use a discrete conductor to connect every decoder chip to every display chip. That's my prediction. I have seen a few applications, well, actually more than a few. I've seen applications where you can even get away with eliminating the latches. I don't know if you could do that in a frequency counter. Maybe. There's some pretty creative solutions out there to do so. But that's my prediction. Discrete, and I don't even know what type of chips it runs. I'm going to say the original 7400 series. No LS, no low power Schottky, no high speed CMOS, and for damn sure it's not using the CD 4000 series of CMOS chips. So I say I'm predicting 7400 series TTL logic. Now let's talk failure points. Regardless of whether it's this topology or this topology, I know it's not this. It's too old. But let's say if it were, where am I going to guess my? Well, we already know the display segments are missing. Are they burned out? Yeah, boy, I bet not. I'll bet everything I own they're not. So you've only got a couple failure points, regardless of whether the LED displays are socketed or soldered to the board. Remember, it's a Heathkit. Before you clown on Heathkits, clown on yourself if you can't solder. So you've got a failure point where that display meets conductor, regardless of the fashion that it does so. You've got irregardless of whether this chip's socketed or not, the decoder chip, you've got a failure point there. Not much else. If a whole display were blank, that would bring into other possibilities, but there's really very few, and that, what I've just said, would apply here as well. Hopefully the chips are socketed. Anyway, I'll record a video, and hey, wait, I'm a baby boomer. We don't record videos. We film movies. So whilst I clown on myself, I'm going to probably go ahead and take it apart and repair it. And I'll show a quick update to the video, to my film, and explain what I found. Now, I don't know if this was of any interest or any value to you poor souls that witnessed this big event. The event being my very first resurrection video. One moment. You know what, man? I just wasn't comfy sitting there behind that. Behind that. Now, I felt a little more comfy there. Now, so for the perfect classless outro from the antiquated workbench of N8NK, I wish you well, and I wish you have a great day. 73